In this video, we'll test out all the knowledge you've learned as part of this video course. We will do that by writing a tic-tac-toe game with an unbeatable AI. We will also test out the AI by making it play itself 10,000 times. So grab a cup of coffee, make yourself comfortable, and code along with me. Let's get right to it. Okay, so what we're going to do to start is set up a new project. So File, New Project, and I'm just going to call this TTT. I'll open in this window. Okay, so we got an empty project. First thing I'm going to do is set up some packages and files. So Python package, we're going to call it engine, because this will be the Tic-Tac-Toe games engine. And in here, I'm going to want 3 files maybe. So Python file, let's have one for the board, so the play area. The second one, let's say game, to control the actual running of a single game. And then lastly, let's have a players file. And then in the main root directory below engine, we're going to create a new file, and we're just going to call it main. And that wasn't a Python file, so I need to rename it .py. Okay, let us start off with the board. So if we create a class called board, and we're going to define a constructor, and if you remember, that is underscore init underscore. And if we think about Tic-Tac-Toe, you've got this 3x3 board, so there's a total of 9 slots where you can place something. So we need a data object that can store that. And the easiest thing I can think of for that is a list. Actually, I'm just going to multiply a list by 9. That should create 9 empty slots. And you'll notice I'm doing this here. I toyed with the idea of doing none. There's trade-off to that. So this should create me a list of 9 slots that are all empty. And then, as I mentioned, the board is really split up into 9 cells. And we're going to use the numeric keypad 1, 2, 3, 4, 5, 6, 7, 8, 9 to draw out that board. Now our list will start at 0. We could add a 0 cell that we leave alone to make everything easier, but I don't want to do that because it wastes memory. The other thing we need for our board is the current move we're on. We're going to need that to simply tell if the game is over or not, because the game is over if we've placed 9 things and no one has won. And the current move is going to equal 0. Okay, next thing we want to do is let's create a class that makes a move. So process move. And for this, we're going to pass in 2 things. The first is a number to tell us which cell. Let's call that position. And the second is going to be a character which identifies the player. So player marker, and that is a string. Okay, so what do we want to do when we move? The first thing we have to do is make sure the cell isn't already occupied. Well, actually, we need to make sure it's a number. Now, because we've declared this as an int, we're going to actually make the person calling it responsible for checking if it's an integer. I'm not going to bother. What we're going to do is check that it is between 2 cells. So if 0 is less than or equal to position, and position is less than or equal to 8, then that means we're on the board. And then we'll do and self.board reference position equals a single space string. Then we know now that it's within range and that it's an empty point on the board, so we can move. Actually, I'm going to create a variable called placed, and that will be set to false. And if we pass this, we're going to say placed equals true, and we're going to say self.board position equals player marker. And that should be an assignment, not an equality. Why is that complaining? Redundant parentheses. That's better. And then we are going to return placed, which will either be false or it will be true. The other thing we need to do is we need to increment self.move plus equals 1. So that will increment the move and it will set the position on our board. Okay, so let's start testing this out as we go along. So I'm going to do if underscore name equals underscore main. And you remember we talked about this last week, and that should be a string. And we're going to create a new board, so game board equals board, game board dot process move, and let's do 1x, and then placed equals the return of that, which will be Boolean. Let us say this returns Boolean. Shadow name from out of scope. Oh, I know why. We name this move made. And then we're just going to print if move made, print moved, else print failed. Wrap those in quotes. Okay, let's put another space there. And then if we run this file directly, we moved. Now the question is, if I copy that process move and do it again, the first time it should say move, the second time it should say failed, because you shouldn't be able to place There you go. Let's just check that by putting in a 9, which is out of scope. That fails. And then let's try a 2, which should now succeed. Moved and moved. Okay, so moving is working. The next thing we want to do is work out if the game is over. And the way we can do that is def game over. And we're just going to return 9 minus move. Because once we've made 9 moves, we've filled up all the slots. And that should be self.move, of course. And then this is just going to return... Actually, no. Equals 0. Because I want it to return a bool. And then to test this, we get rid of that. And we're going to do for ID in range 9. And this should be ID to X. And then we're going to say print. And let's do if gameboard dot game over. Game is over at ID. And we just make this a format string. Test that out. We didn't put a colon. Game is over at 8. And it's 0 index. So that's right. We filled all 8 slots. Oh, that's a point. This is wrong. Actually, how did this work? Oh, because ID, it starts at 0. So it filled the board at 0. If we'd done for ID in range, let's change that now to ID. Let's just say ID plus 1 for ID in range 9. And then ID in. So this is a list comprehension. It's going to basically take every ID from here, add 1 to it. So now we start at 1 instead of 0. And what you'll find is this won't actually say game over. It will finish. And the reason is that 0 was never filled in. What we need to do in process move is we need to set the position to -1. Because if they type in 1, we're actually putting it in cell 0. And now the game should finish as expected. And it didn't. Why didn't it? Oh, it's throwing out 9. That's why. It's not actually processing 9 because it was above 8. There you go. Game is over at 9. That took a while. Okay. Next thing we want to do is work out if someone wins. This is a little more complicated. And I want to set up some variables. We're going to set up rows, cols, and diagonals. And in there, we're going to store a set of tuples. And this one for row is going to be you can win if you get 0, 1, and 2, which is 1, 2, 3. We can win if we get 3, 4, 5, which is the next line. And we can also win if we get 6, 7, or 8. For columns, actually, let's just copy these because they're going to be fairly similar. We made this a lot more difficult than it needs to be. 0, 3, 6, 1, 4, 7. I'm basically working my way up the number pad for each column, and I'm minusing 1 off the number. So this one will be 3. No, it won't. It'll be 2, 5, 7. Is that right? No, 2, 5, 8. Double check that. 0, 3, 6, 1, 4, 7, 2, 5, 8. And the top one was 0, 1, 2, 3, 4, 5, 6, 7, 8. And our diagonals, there's only 2 of these. I'm still going to copy the row above. And these are going to be 0, 4, 8, or 2, 4, 7. How did... No, 2, 4, 6. Didn't minus the 1 off the last number. Okay, and then our checks for a win are going to be rows plus cols plus diags, lowercase d. Def winner, and it's going to return the character of the winner, so it's a string. Don't need 2 colons there. And the way this is going to work is for result tuple in checks. Well, actually, for check in checks. I did call that checks, didn't I? Yes, but it's in object scope, so it should be self.checks. And then what we're going to do is if gameboard check 0 gives us the first number from the array, from the check, so for the first instance it would be 0, equals, and this is just going to be a copy-paste job, check 1. So what we're doing is we're checking each number in the tuple to see if they're the same. And then what we want to do, and we need an and between all of these, so if check gameboard, what am I doing here? So if this equals this, can I just do does not equal a 0-length string? I think I can chain like this. Let's create a variable for winner. And we're going to set winner equal to this. Doesn't matter which one it is, because they all match each other. Don't need a semicolon, wrong language. And actually, gameboard isn't gameboard, it's self.board. I wish I'd spotted this before I copied and pasted. Now, what I don't like is this goes too far. So I'm actually going to take this. I'm just going to break it down like that. And this should be self-board. And then we're actually going to break out of a for loop. And this needs to be indented. Oh, we need an empty bracket there. And this actually, does this need to be indented that much? Yes, it does. And then we're going to return winner. And then we're going to change this to if gameboard.winner does not equal a zero length string, or sorry, a space string, then we are going to print gameboard.winner, one after play. And then if this occurs, we're going to break out of this loop. So let's try running that. One after play number 1. That isn't possible. I think we need to do and self dot, actually, let me just copy self.boardcheck0 does not equal that. Let's try that again. One after play 1. And actually, it's zero length string one after. It is a space. It's being returned as a space. I'm confused. This is over indented. It needs to be there, maybe? Try that. One after play 1. It doesn't win. Oh, you idiot. Actually, call the function. X1 after play 3. Okay, that's it. Now, a couple of things I don't like. And that is that I have to call a function for these, both the game over and the winner. We can actually avoid that by just saying, if we go at property, with a space in there, what that will do is it will tell the system that actually just calling winner is fine. And under the hood, it will convert this to a property. So instead of having to call the function, we just call the value and it returns it as if it was a local variable. So on that, and it still works, but we no longer need the function call. Okay, and now what we want to do is build a way of rendering the board. Def render. And the logic for this, I want to do it as quickly as possible. First, we're going to need to actually render the blank parts of the board. So let's create some strings. The vertical padding. And that is going to be 1, 2, 3, 4, 5, 6. Pipe. 1, 2, 3, 4, 5, 6. Pipe. 1, 2, 3, 4, 5, 6. I'll probably screw this up and have to adjust. HPad is going to be 1, 2, 3, 4, 5, 6. Space 1, 2, 3, 4, 5, 6. Space 1, 2, 3, 4, 5, 6. One of those is longer than the others. That one? Did I do 6 or 7? 1, 2, 3, 4, 5. I did 7. So what do I need to actually render a section of the board? I need to render a vpad. So actually, let's create a string for output. That's going to be a zero length string. Output plus equals vpad. Output plus equals... Right, let's put this in a loop. Let's create a counter. Board index. And then while board index is greater than or equal to 0. And then we're going to do output vpad. And actually, board index, let's set to 6. You'll see why in a minute. Okay, so this is going to be the actual rendering of the row. So 1, 2, 3. And let's make this a format string because it's going to have stuff in it. And then we're going to put self.board index. Okay, so this is the top row of the board, and we're rendering into it slot 6, which is keypad 7. So it's the left-hand first index. Then we want to do, how many spaces did I do here? 1, 2, 3. So I think this is 1, 2, then the pipe, then 1, 2, 3, another board index. And this is going to be +1, 2 spaces, pipe, 1, 2, 3, and we'll do board index +2. So 6, 7, 8. And then what we're going to do is we're going to render another vpad. Then we need to do output plus equals hpad. That's going to draw the delimiter to cut the board now into the next section. Then we'll repeat, and then we'll repeat again. So we're going to do board index minus equals 3. This will reduce it by 3. So the next row will go to 3, 4, and 5. And then it'll go down again to 0 and run it because it's greater than or equal to 0. But it will print this row again, which we want to get rid of. So if board index is greater than 0, then we're going to print this because we don't want to print an extra row at the bottom. 2 spaces should be here. Okay, I think that will render the board. Now to test this, I'm actually going to set the player marker to the string of the ID. So I'm going to render numbers in the board. And then after each go round, we're going to render the board. Actually, no. Let's render it at the end. So I'm only rendering it once. So self.render. Now that isn't going to do anything because I forgot to print. Oh, I can't see self.render. It's got to be gameboard.render. And then let's actually print the output. This should be outside the loop, of course. Okay, let's give that a test. There is an issue. While gameboard is greater than or equal to 0. What line is that on? Render. I don't know why I did that. It should be board index. Whoa! That was not what I expected. It's in the for loop. Now, can you guess what the problem is? We need to put a new line on the end of these. So escape N, escape n, and then at the end of here, we are going to have to put in our 2 spaces and then escape n. Okay, let's try that again. I think we're actually going to make these 5 because it looks wonky. And then I just take the extra space out of these rows. And there we go. That looks much better. So 1, 2, 3, 4, 5, 6, 7, 8, 9. They are the key presses we are going to make. So we have a board that will work now. What do we do next? Let's get the game actually running. So let's create some players. So we're going to create a class in here of base player. And actually, let's make this an abstract class. So we're going to import ABC, and then base player is going to inherit from abc.abc. Now the player is also going to need a copy of the board because they're going to actually have to place things on the board. So from dot import board, and for now when we create a computer player, I'm just going to use random. So from random import randint. Okay, that should be enough for now. So in here I want player. And let's create a constructor, def underscore init, self.player marker equals, let's actually input it, at abc.abstract method, def make move. And this is just going to pass because I don't want anything in it. So this is the sort of beginning. I forgot my colon. This is the beginning of each player we're going to create. So first off, we're going to create a human player. So class human player. And this is going to inherit from base player, def init. And this is going to take a board. So when we create the player, we're going to pass in a board to it. And that is going to be of type board. And we're also going to pass in a marker. That needs to be a capital B. And we might as well, as we've done that, set this to string. I call board lowercase b. No. Oh, that should be from .board. Import board. That's better. Then this should stop whinging eventually. Okay, so in our def init, the first thing we're going to do is call super brackets dot init, and that is going to pass in the marker. That will set the player marker there, if I actually spell it right. And then we're going to do self.board equals board, and that should be it. And then we're going to write the ability to make a move. So def make move. And let's create a variable called placed, because I think that's what we called it in the original. And that's false. And then we're going to take a user input. Is numeric false? And actually in front of this, while not placed. While not. Don't know what it is today. I keep forgetting to type equals or colon. While not is numeric. And then let's get the user's input. The prompt is going to be, and actually that's a little verbose, so we're just going to change that to enter move. And this is going to go into a variable called selection. And then if selection dot is numeric, we're going to set is numeric to true. So this will skip this loop. And actually, I think this actually needs to be, no, it doesn't. It's fine. Is it fine? Yeah, it's fine. Let's do move, set that equal to 0. No, -1. So then here we're going to do move equals selection. Let's actually set move to an int. Is numeric to a bool, placed to a bool. So what's going to happen here is we're going to check for a move and then make move equal to selection. Why didn't it like move? Local variable move value is not used. I'm setting it right there. Oh, because it's not output yet. And actually it's not output at all, but if we go back to this while loop, so now we're now in the placed one. So we got a number, it will keep looping until we get a number. And then what we're going to do is board dot process move. We're going to pass in our move, and we're going to pass in our own player marker, which I think is self.player marker if memory serves. And then we're going to set placed equal to board.process move, and that it's erroring because it should be self.board.process move. So if you remember, when the board succeeds to place, this will get set to true, which will exit this loop and then exit the function. So this will actually keep trying until you can make a valid move. Okay, so now we go to human player. It's time to actually write the game loop. And for that, it's going to import board, and this is from dot board import board. from dot players import human player, and then game board equals board. Did I actually do that? No, it's passed in, so that's all right. So this will create our empty game board. We're then going to create two players. So player 1 equals human player, and this requires the board we just created, so game board. And it also requires our player marker, which is going to be X. And then we're going to duplicate this down to player 2 and just toggle this to O for noughts and crosses. And then while not gameboard dot game over or not gameboard dot winner. So if the game is not over and the game doesn't have a winner, then we loop. And let's just say if player, so actually up here, let's create a new variable called player. Actually current player. And let's make this equal to player 2. And then if current player equals, so the idea behind this is I want to flip the player if it's not the current player. We haven't yet written any way of saying, am I the current player? Because we don't have a way of saying, is this player equal to this player? So we need to actually add that. So to write if something is equal, and actually we need not equal. So def, and I think it's for not equal, I think it's NE, this one. If you want to do equals, it's underscore underscore EQ underscore underscore. So not equals, and other is the other player. So this is going to be a type of base player. I don't know if I can do this because it's the same object. Let's see. If self dot player marker does not equal, and actually let's just return this because it's the same thing. Return self dot player marker does not equal other dot, yeah, it's not accepting base player. I'm going to take that out for now. And we're just going to put in player marker. So now whenever you check if a human player is equal to another human player, it will check the player marker to see if they're different. I think I need another line in there and another one in here perhaps. Yep. Okay, so if current player does not equal player 1, current player equals player 1. So if the current player is not player 1, it's going to become player 1. Else, it's going to become player 2. And then we're going to ask the player to make a move. And we're going to do that by saying current player dot make move. And that should prompt us then to make a move, and we'll make a move. And then once we drop out of this loop because the game is over or we have a winner, we are going to print who won. Here's the thing with this. Once we exit this loop, we know the game is over. So we only have to check one of the two conditions. Let's do this. If gameboard dot player, not player, dot winner does not equal a space, then we're going to print, and this is going to be a format string, player, and then it's going to be gameboard.winner. Won the game. Else, the game is a tie. So we're going to print game was a tie. Okay, let us test this out. I'm sure I've missed something. Game exited with exit code 0. Attempted relative import with no known parent package. What? Oh, you idiot. No, that should work. We're in the same... I'm going to try and change that to engine. I'm not sure why it's doing that. I'm sure that worked in the past. Let's do engine.board and engine.player. Okay, that worked. So I'm going to enter my move. I forgot something pretty big. Let's stop that. What I forgot was rendering the board at the end of each move. So current player.makeMove, and then we're going to do board.render. So gameboard.render. So enter my move. I'm going to go 1. Something blew up. Got something rather big. Move is going to be the int of selection. Go back to game and run it. Enter move. Try again. 1. Okay. Let's make this a bit bigger. The next move is going to be 2. Didn't want that. I actually wanted 4, 5. Actually, let's just test that I can win. So 4. This player is going to do 5. And then I am going to do 7. The game didn't finish. Why didn't the game finish? Is that a problem with my game? 0, 3, 6. That should have matched. I'm an idiot. This isn't none. So that won't match unless that is a space. Same as we did there. And this should actually be equals a space because it's the winning run. Okay. Let us stop. We're going to try again. Enter move. I'm going to move 1. Enemy's going to move 2. I'm going to move 4. It's going to move 5. And we're going to move 7. And it still didn't finish. Actually, let's go to that not and just put does not equals that. This needs to be an and No, it doesn't. Yes, it needs to be an and because it's either of those. Game was well, it wasn't a tie, but gameboard.winner does not equal. It was right the first time. Okay. One last try. 1. Player X won the game. Perfect. Right, the reason that has to be an and is they're not conditions. So while the game is not over and the game doesn't have a winner, if it's or, it will never finish unless we've run out of spaces, so the game is over and the game board becomes a winner. At that point, the game will end. Okay, let us try once more. This time we're going to try and simulate a tie. So press play. I'm going to do 1. Computer's going to do 5, or I'm going to do 5. Then I am going to do 9. It's going to block with a 7. I need to block the bottom corner. And I'm actually so bad at this game that I've actually created a position to win in either case. So let's block 6. I am then going to block 4, or it's going to win next turn. But I could just win right here, but I don't want to do that. And then it's going to put a marker in 2. And I'm going to put a marker in 8. Game was a tie. Okay, perfect. That is our game. Now what we're going to do is write a computer player to play against. And the computer player at first is just going to create random numbers. So let us go to players. And we're going to do class AI player, base player. And then we're going to do def init. It needs a board. And it needs a player marker. And again, it's going to call super brackets dot underscore underscore init. And it's going to pass in the marker. And we are going to do self dot board equals board. And then let's implement our base move. And then we need to check to see if we've placed. So placed equals false. And then while not placed, we're going to do place. While we haven't placed a marker, we are going to do move. Actually, let's not do that. Let's just do self.board.processMove randint 1 to 9. So it's just going to keep making moves until it actually gets one that lands, and it's going to set placed. And obviously, we need to do self.playerMarker. So now back into our game, we are going to do player 2, and it's going to be an AI player, and I need to import AI player now. And let's just spin up the game again. 1. Computer's made a move. I'm going to do 2. Computer completely at random blocked me. I'm going to do 7. Let's actually make this bigger so you can actually see it. And then I'm going to win. Okay, so the AI player is really, really bad. Let's make an improvement to that, but first let's change our game loop. Before we start, we are going to do players equals -1. While players not in 1, 2, 3, no, 0, 1, 2, we're going to keep asking. And we'll take input of players, and this is going to be how many players? And then if players dot is numeric, we're just going to do players equals int players. So if we enter something valid, it's going to work. Otherwise, it's just going to keep the old value and loop through. And then what we do here is at player 2, if players equals 2, player 2 is going to be a human player. Again, game board, game marker. Else, it's going to be an AI player. Okay, let's try this again. So I'm going to expand this window. Play 1. Okay, the computer's playing now. 2, 3, and I won. Let's try 2. We play again. 2 players. Oh, I inadvertently won the game without realizing it. Okay, now it's time to implement a real AI to play against. And for this, we're going to use an algorithm called Minimax. I watched several videos on Minimax and watched a guide and then coded my own version of it. It took me quite a while to get it working, I've got to admit. If you do want to try and work out for yourself how to write one, there's plenty of sources on the internet. And I'll explain as we're writing Minimax roughly what it's doing. So the first thing we need to know for Minimax, let's define it, is the current player, the max player. And this is going to be a bool. A minimax is going to be a recursive function, so it needs a stop point. I think it's called a baseline. So we need to do if self.board game over, or self.board.winner does not equal a space. So if the game is won, we're going to set the move equal to -1, because there's no move that can be made here. And then we're going to set a variable called best to, and let's do self.evaluate score, which I haven't written yet. Let's make that equal to. And this is going to whinge because it doesn't exist. So let's write that now. Def evaluate score. And what we're going to do here is work out if we won or if we lost and set a score appropriately. And the way we do that is if self.board.winner does not equal a 0-length string, then someone won. And then we do if self.board.winner equals self.playerMarker, then that means we won. Else, the enemy won. And what we're going to do here is set a score to 1. Else, we're going to set a score to -1. So we gain 1 point for a win, and we lose a point for a loss. And if we drew, because if we come in here, we have to have either won or drawn. If we drew, then we'll fall into this else block, and the score is going to be set to 0. So what this means is if we win, we get 1 point. If we lose a point. And if we draw, we get 0 points. So what this is going to do, if we fall into the else, no one's won, the game isn't over. This is actually going to make moves, and actually not just moves, all moves to the end of the game, and give a score for which move gives you the best score. So first, we need to set something up. And actually, for the computer player, I need to know what the alternate marker is, i.e. the enemy marker. Let's put this out in it. So if self.marker equals an X, self.alternate marker equals an O, else it's going to be set to X. And that needs to be double equals, of course. This is just marker. Okay, now what we need to do is work out what best score starting point is. And we're going to do best equals -2 if is max. Else, it's going to be 2. So this is a different way of saying if. It basically says, make it this value if it's this, else make it this. It's a shorthand way of doing if else. And then what we're going to do is actual player marker equals self.marker or player marker if is max, else it's going to be self.alternate marker. And this is so when we're making the moves to the end of the game, we can pick which player we are. Because if we use our player marker every time, we're going to win every time. Now, before we write the AI code, we're going to have to make some changes to board. Okay, so back in the board file now, and there's a couple of things we need to write. The first code we need to write is how to work out which cells are still playable. So let's do def playable cells, and this is going to return a list. And then in here, we're going to return, and we're going to do a list comprehension. So let's say cell ID +1, and then we're going to do for cell ID, cell in enumerate, and we're just going to enumerate self.board, and we're only going to list these if cell does not equal that. Oh no, if cell equals that, because we only want the cells that are still playable. Now hopefully, as we go through the game, this will reduce the number of cells in total we have left, and this will allow the AI to work out what calls it can make. Now on playable cells, it's kind of that thing where you want the value, so I'm going to make this a property as well, so that under the hood the method's being called for us. Now, the other thing we're going to want to do is actually be able to roll back a move, because the AI is going to make multiple moves. Now, we could make copies of the board each time, but that's going to get really heavy. So I want to be able to roll back those moves. So what do we need to do that? First thing we're going to do is build a little log of the moves we've made. Let's do self.movelog equals an empty list. And then in process move, as well as doing this, we also want to do self.movelog.append, and we're going to append the position, but not -1 this time, because we want the actual position. And then we need the ability to actually reverse a move. So we're going to do def undo move. And how can this work? Well, couple of things. First, let's pop the value off the move log. So let's create a variable called last move, and we're going to make that equal to movelog.pop. So this will pop the last thing off the list into last move. And then what we're going to do is we're going to do self.board position -1 equals and we're going to set it back to a space. And then what we want to do is self.move minus equals 1. And that's not position, is it? It's last move. So the first thing we do is pop off the last move from the move log. That means the next time someone calls this, they'll get the move before, which is exactly what we want. Then we're going to find the board position that is with that, which is the last move minus 1, and set it to a 0-length string. And then we're going to set the move counter back 1. I think that's all we need to do for undo. I think that is all we're going to need, but I do want to be able to let the computer play itself multiple times without creating a new game environment. So let us create a def reset. And this is going to allow us to reset the board. And all we're actually going to do here is take these values and just copy them in. Although actually, we don't need to recreate the move log. We could just clear that. Everything else looks fine, I think. Okay, so we can now reset the board to start a new game, and we can undo the last move that we made and work out which cells are still playable. I'm going to be brave and not test this. Let's go back to players, and let's finish coding the AI. So what we're going to do here in this else, after we've set these, we're going to do for, let's do possible move, in, and I think this is self.board.playable cells. Remember, we don't need to call the method because we made it a property. And then let's do self.board.processMove. And in here, we're going to pass in the possible move. And we're also going to set the actual player marker. And then we're going to do something interesting. We're going to do score, comma, underscore equals self.minimax. And then we're going to pass in not is max. And this is going to whinge because we haven't returned anything. So actually, let's do that. Let's return best and move. And move isn't created in this context yet, but it will be soon. And then after we've made this move, and let's talk about recursion first. So what's going to happen is this is going to call the next move in the line, and then it's going to call another one until we reach the end game. And then once we reach the end game, all of these will start to unravel back. So we'll come all the way back down the chain and return the score for that branch. So if I'm the third move and I move a 1, it's going to score all the possible outcomes of 1 as a minus or a plus or a 0, and then the computer can work out what that score actually means and whether we should continue. But after we've made the move, and then the Minimax has made its move, we need to actually do self.board.undoMove. So now the Minimax has made its move, it's now going to undo it and try the next move. It's basically looping through each possible move, which will then call the next possible move down the chain. This bit is where it gets interesting. If, or... And this logic is going to be if is max and score is greater than best, or not is max and score is less than best. Okay, so what's this doing? If we are the is max, which is actually the computer player that is currently moving, then if our score improves, i.e. it's already better than the best score, then we store it. If we are the opponent player, which is trying to minimize your score, then we only score it if score is less than best. So we're constantly trying to improve our score, and the enemy computer is constantly trying to lower our score. So this really kind of evaluates if you are playing the perfect player. They would be maximizing the loss on you, and you want to avoid that. So what we do in this loop is we set best equal to score, and we set move equal to possible move. We missed an A out of evaluate, and we didn't actually return a score, so let's return score now. So that will stop whining. Score is set here. What's it whinging about? Nothing. It's just because score selected. Is it? No, why is that? Might be referenced before assignment. It's definitely going to be assigned. Oh, no, I'm an idiot. This needs to be inside the loop, because each go around the loop, if the score beats, we need to increase it. Okay, now that's going to whinge because it could be referenced before assignment. In reality, it's never going to be, but PyCharm just doesn't know that, so it's going to warn you. The way to get around that is to sort of set a variable move up here, set it to 0, and then override it. I really don't want to do that. Now, when we're testing the computer player, and actually we need to do some logic here as well to actually make this work. If we just use Minimax for each turn, the problem we're going to have is every game is going to be exactly the same, because the computer will always evaluate the same thing as best. And so how we can get around that is still make the first move random. So we are now going to, and place no longer plays a part because there's always going to be a place. So what's my logic? First, if self.board.move equals 0, i.e. it's the first move, then we are going to set the move to random. Let's get rid of that. And actually, instead of move, let's use the word cell. If we're not the first move, then we're going to do underscore cell equals self dot minimax. Is max is going to be set to true. We're then going to do underscore equals self dot board dot process move, and we're going to move to cell, and we are going to set self dot player marker. To test the AI here, we're going to play the AI. If it makes the worst moves possible, one of two things is wrong. Either we screwed up the board logic for undo, or we've got minimax wrong, in which case it's no longer trying to maximize its score, it's trying to minimize it, so it will be actively terrible, worse than a random number even. It deliberately tries to throw the game. Just a note on this, because I don't think we've talked about it a lot before, if you have a variable returned from a function and you don't actually care for it, i.e. you're never going to use anything with it, if we actually created a variable, you will get this warning that this variable is not used. By using underscore, you tell the system, I don't care about what's about to come back. Don't whinge at me. Now, when we call minimax here, we don't care about the actual move. We care about the score. However, when we call minimax here, we care about the move and not the score, because at this point, we only care about what the move to make is. And then we're placing, we know the place will be valid, as presuming we haven't screwed anything up, so we can ignore whether it was placed or not. Okay, so are we brave enough to try playing a game against the computer? Let's give it a go. I'm going to go into game and we are going to execute. Let's make that bigger. How many players? We are going to go 1 player. I am going to go in 1. The computer's made a move. It's gone central. I am now going to go 9. The computer has now moved and is going to win unless I block it. So let's block it with 8. And now the computer's got another opportunity in 3 and 4. We tied. Minimax is working, I'm pretty sure. So now what we're going to do is we're going to code the computer to play itself. And the way we need to do that is exactly what we did here, which is going to be if players is greater than 0, then player 1 is going to be a human player. Else, player 1 is going to be an AI player. And obviously we need to pass it the game board and the marker. Okay, and then the second player is exactly the same as before. So now if you run the game again, and we're going to say how many players, and that number is going to be 0. The computer will now play itself, and the game was a tie. And if we run this a couple of times, the game should be a tie each and every time. And you can actually see all of the moves the computer makes. That's all very well and good, but I promised you the AI would play itself 10,000 times. This serves 3 real purposes. 1, it recreates the scene from the end of War Games. 2, it's kinda cool. And 3, it tests the AI. Because if the AI is doing its job, the computer will always tie with itself. And that's because Tic-Tac-Toe, if you're really good players, you will always draw. You will never ever win or lose. So how do we make the computer play itself 10,000 times? Well, we need to rewrite the code a bit. And for that, I think we're going to create a function in here called def play game. And we are just going to enter players. Or actually, let's call it human players. Because it could be 0. Let's make that an int. And then we replace this. Let's actually cut that out. And let's change all references to players to human players. Refactor rename. And we're just going to do human players. And then what we're going to do is in main, let's just copy that. And let's from engine.game import play game. And then we are going to ask for how many players. If players equals 0, and actually before we do that, let's set a variable actually up here. And this variable is going to be called runs. And it's going to be 1. And now what we're going to do is if players equals 0, i.e. we're a computer player, we are going to do this again. But while runs, and actually here we need to change something. Runs here is going to be set to -1. And while runs, actually I'm going to avoid that. We're going to do temp runs equals -1. Then we're going to do while temp runs equals -1. And then we're going to do temp runs. I should have refactored this. It would have been way quicker. Okay, so now we've got temp runs. And then at the end here, actually, let's just do runs equals int players. And instead of players, it's going to be temp runs. Okay, so this will give us the number of games we're going to play. And then what we need to do underneath this, and actually, let's create some timers. So let's do import time. And first we're going to do start equals time.time. Now when you do time.time, it gives you seconds. Then we're going to do end equals time.time. And then within between the start and the end time, we're going to do for x in range runs. We are going to do temp equals play game. And we're going to pass in the players. And I need a semicolon there. Not a semicolon, a colon. And then actually, we need to work out who won and who lost. So let's add that to game. So def play game, we need to indent all of this. Otherwise, it's not going to work. So grab all this, press tab. Oh, I missed that one. I even missed colon there. And then at the bottom, we are going to return. What are we going to return? The winner. And let's do, state equals gameboard.winner. That will either be an X or an O. And then we'll do state equals tie. And then we're going to return the state. And it's going to whinge. No, it's not whinging. It knows that here it's one of the two. Okay, we're good. So this is really going to return either the player marker that won or the word tie. And then if in our main we do that, maybe, and let's make a dictionary. And then once we play the game, temp is now going to have the player who won. So we're now going to do count equals stats.get temp. If temp isn't found because that hasn't won yet, we're going to set 0. So count will be 0. And what is wrong with me? Equals. And then we do stats temp plus equals 1. Actually, no, it's just count plus 1, isn't it? So to summarize, for each game we play it, we get the result of the game. We basically look up the value in the stats table and increase that count if it wins again or if it draws again or whatever. And then at the end, we are going to print the stats. And we're also going to print the end minus the start to get the total time it took to run that many iterations. So we've made quite a few changes there. Human player's value is not used. Oh, that is because we were setting it there. Let's just scan through the code. PyCharm's telling us everything's good there. Let's just go through the warnings. Line is too long. I don't care. Expected 2 blank lines after... Okay, we can do that. Shadow's a built-in name. Change that just to be useful. So IDX. That is going to be IDX. In fact, we don't need this anymore. It can go away. We've finished our testing of our board. Typing in Word, I really do not care. I mean, the key thing is we got the tick. Game is a tick. Main has an error. Players has errors. Local variable move might be referenced for assignment. Don't care. White space after colon. That I will fix. And then main. Main is whinging. Players can be undefined. Let's do players equals -1. Okay, we got a tick. I do want to make one last change in game. If human players is greater than 0, then we are going to render the board after each move. If human players equals 0, then we are going to render the board. So gameboard.render. And actually, I didn't need to do reset board because we're just recreating it every time. I can live with that. Now, what I want to do here is when the computer's playing itself, I really do not want to have the screen just filling up with boards. So we are going to print. And I happen to know that if we do a certain set of characters, so we're going to do a functional string, then we're going to do /033, then we're going to do an open dictionary bracket, 0. Actually, no, not 0. I think it's 1. So I think the Windows terminal is 1.1 and then 1H. And I think, if I'm right, that will actually reset the board after each run. So let us go to main now and test this out. Actually, it will not work in this terminal because this terminal doesn't work the same way Windows does. So here I open a command prompt and we're going to do Python main.py. How many players? We want 0. What's wrong with 0? Did I? Idiot. Games. Okay, let's try this again. How many players? 0. How many games? 10,000. Okay, that didn't quite go to plan, but it is doing exactly what I asked it to. Let's cancel that. So the problem we had there is that it was writing back to the 0 cursor position, so it was flipping the cursor back, but we'd already got crap on the screen. We need to clear that. To do that, we're going to use the OS, so import OS. And then I think if memory serves, it is os.system. And then what you would type at a command prompt clear, which would be CLS. If you are in Linux, I think the word is clear instead. So after we've entered our numbers, the screen is going to clear and then it's going to start rendering the board, which is exactly what we want. Let's pull this back over. 0 players, 10,000. Is that too many? That's 100,000. Oh no, I've run 100,000. That's a terrible idea. 0 players. Actually, it might be really nice to actually count the number of games we're playing. So after we run the board, okay, we're just going to do print, and let's do an F, game played, and let's do a colon, and then we're just going to do X, which is the current game counter. And actually, I think it's X plus 1, because 0, the first game will be 0, and we don't really want to put that. Okay, third time's a charm. Python main. How many players? 0. How many games? 10,000. Execute. And there we go. Tic-Tac-Toe is being played by the computer against itself, and so far, it's always been a tie. Now, I'm not going to bore you with watching all 10,000. We will come back when 10,000 games have run. If you've been coding along with me, you'll be able to run this at home, run it 10,000 times, and you'll see. And with that, I will be right back with the result. Okay, our 10,000 games have been played. Total time was 982 seconds. That is an average of 10.2 games per second. In all 10,000 cases, the computer tied. So our Minimax is working perfectly. Now, in case you're interested, I also rewrote this program in C++ just to see how much faster C++ is than Python. I was absolutely astounded by the result. If you want to hear more about this, let me know in the comments and I can make a video on it. Speaking of which, my next video will be on time and how we'll become a lord of it within Python. You'll find that top left right now. If you found this video useful, then please leave a like and consider subscribing. And with that, thanks for watching, and I hope to catch you on the next one.